So tell me more about the history of PBS, because I understand you had an anniversary. Well, what's the story behind that?
So June 17th, 1991, the PBS project got started at NASA Ames Research Center.
Yeah.
NASA's the place actually that brought us Unix on supercomputers.
Mm-hmm.
They got one of the original Cray ones, and they did that. The other thing they did is they actually created NQS, which was this very original batch queuing system.
Yes.
But in the early 90s, they realized that NQS was great for serial systems. Wasn't going to work for all the parallel computers that were coming up and that were going to be all over the floor here for the next 20 years.
Yeah.
So they started a project to build, to standardize batch queuing, because NASA's into standards, and then also to build a piece of software that actually implemented that standard and would take us forward. Okay. And that's what became PBS Professional.
So that's the origins of it, but you're saying it was just a project then? It wasn't like a product or something?
It just started out as a project.
Yeah.
Took a couple years to actually, write all the code, to get everything going. It got got deployed really for the first time maybe on an IBM SP system.
Okay.
It's one of the larger ones.
Oh, yeah.
Maybe that was in 1994, 95, somewhere around the 96. Okay. I don't even remember the exact dates.
Yeah.
And that's when it became sort of the PBS stood for originally portable batch system, because one of the problems with NQS was it didn't run everywhere.
Okay.
So they really wanted something portable, but it's really was focused on parallel and distributed computing. So SP was its big thing.
Yeah.
At that point, several other big centers around the world started playing with it and using it.
Yeah.
But it wasn't until 1999, 2000 that in 2000 we made a commercial product out of it, PBS Professional.
Okay.
But in 1999, as part of NASA, we also released an open source version of it, which became OpenPBS, and is still hugely widely used in the industry.
Yeah.
Maybe 30,000 people worldwide or something. Although not so much in the United States, but definitely in China, in Europe, in life sciences and stuff.
Yeah, I mean, it's an interesting story, because I was working at Cray Research back then. We had a desk side Cray, I forget the Cray EMP, I forget what it was called, but it was like this big.
Yeah, no, I remember that.
But Altair was one of the first customers of that.
Yeah, no, Altair got its start. So in 2000, we took PBS commercial.
Yeah.
In 2003, we were acquired by Altair Engineering. So Altair Engineering is actually older than we are.
Sure.
Altair Engineering got their start in 1985, so that's 25, a little more than 25 years old.
Yeah.
Doing consulting for the major auto companies in Detroit.
Okay.
And we were one of the first users of Cray computers. It's really funny when I talk to the CEO. He's still one of the original founders is still the CEO of Altair, and it's great to talk to him about. He's been in HPC forever. And
I remember the name of the box now was the Cray EL entry level.
EL,
Yes. Yeah. Cool. Anyway, so you're the company that does this consulting and stuff for Detroit. How does that turn into a product like this? I mean, it seems like a whole different business model.
It's actually, what I love about Altair is it's a company built up all of engineers. Yeah. So I'm an engineer at heart and stuff, but the wonderful thing is, even the CEO is sort of an engineer at heart. He comes into engineering meetings and says, no, not that way, this other way. It's not all about business. So, well, in engineering, which got its start in automotive, but now Altair does all sorts of stuff in all over the manufacturing space and aerospace and heavy industry and everything else.
Right.
So although it got its start consulting, Altair sells, and the major part of Altair sells products, software, to do design work, to do optimization work. So to take, to make sure that your cell phone, when you drop it onto cement, it doesn't shatter into a million pieces. So they'll do virtual design work and prototyping and finite element analysis, CFD, crash,
all that,
to design products or optimization to take weight out of wings in airplanes and in order to do this virtual design work, the virtual simulation,
you need a lot of cycles, don't you?
You need lots of cycles. In early 2000, kind of right after we went commercial, Altair realized, in order for people to actually get the benefit from our software, from the HyperWorks software, which is Altair's manufacturing software, they're going to need tons of cycles. They're going to need something to manage those cycles, and so that's when we got together. So it was a really natural fit.
Okay, so that's really the past. What are you guys doing today that's interesting?
We've done a whole bunch of firsts in our 20 years, but one of the things we haven't done in the last 20 years is really change our product much. So in the last couple years, we've started looking forward. We've looked at where we are, and we started looking forward another 20 years. So the original designers did an amazing job building a piece of software that's lasted virtually without the infrastructure's lasted for 20 years, but we think moving forward into 20 years beyond exascale, there's stuff we need to do. There's stuff we need to do in the software. There's stuff we need to do in how we think about how people are going to use computers. And so we've embarked on a whole scalability initiative, of which the first thing has come out. I don't know if you can see it in the background. Somewhere up here it says now 10 times faster. So we're rebuilding our infrastructure to scale up, 10, 100, 1,000 times more.
Okay, so
we hit today's machines at, whatever, 10,000 nodes, no problem. 100,000 nodes, probably okay. Million nodes? Not sure anymore. That's, going up.
Well,
so we're redoing infrastructure.
Yeah, I mean, an exascale system might have 1 billion threads floating around, right? So how do you deal with that?
Well, luckily, we don't deal with that part.
Okay.
We deal with a slightly higher level of, there's only 100,000 different computers, maybe 1 million computers.
Maybe 1 million,
so we don't need the billion threads. We'll deal with 1 million computers and we'll allocate them. But from our perspective, our job is protecting customers from people like us, infrastructure builders.
Yes. Okay.
Hardware, operating system, or anything else. And so we want the reliability, the management of power on these systems are going to be, I think, the biggest challenge is dealing with a system that is constantly failing.
Something's going wrong. Yeah.
And so you sort of need to predict what's going to go wrong and try to stay away from it.
Yeah.
It's going to happen during your job's going to run for 3 hours. It's on 1 million cores.
Yeah.
You don't want one of those to die.
Right.
You want to pick the ones that are, going to run. Some out of 1 million cores, MTBFs, what they are. Some stuff's going to.
Yeah. Murphy's law to the exponential power.
And even today, I've started measuring when I talk to customers and I talk to people in the industry. I've started measuring the size of their systems by how many megawatts they're running, not how many petaflops they're delivering.
Yeah.
Because we're getting requests now, and we're doing some stuff in power management. We're getting requests now of, we have a power envelope.
Yeah.
Help us stay inside that and get the right work done. It's not, don't use cores 100%. Use my 5 megawatts 100%.
Okay. So what So what kind of sizes of megawatt systems are you?
5 megawatts.
What's the scale?
5 megawatts is a pretty big. It's a pretty big thing.
I mean, big machine.
The K system from Japan is huge.
Yes.
But we're not going to get that yet. Nobody's going to start building a nuclear power plant next to their. Well, now nobody's going to build a nuclear power plant.
Yeah, I mean, to put that
next to their machine.
Right. People ask me, well, how much is a nuclear? I think 40 megawatts from
gigawatt. I think 1.5 gigawatts.
Okay. Yeah. So you're not going to take.
If you built an exascale system today, you also need to build a nuclear power plant. So
right next door. Yeah.
The price of your computing, nothing compared to the price of your nuclear power plant.
Okay.
But I think
power
also,
management.
Power management. But also with these big machines, it's going to become more and more important to run the right work. And that's what we do. We run the right work in the right way.
Okay. So this 20-year thing, is it an initiative? Is it a community thing? What is it like?
It's an artifact of being 20 years old, of turning 20.
Okay.
Turning 20. So you have your 20th anniversary, and you're looking back, and you say, well, that was really neat. I didn't know this. I didn't know this was going to happen. And, and then so we look 20 years ahead a little bit, and we joke about what's going to happen. My favorite joke personally is, when I turned 30, I looked back at when I was 20, and I realized how dumb I was. I didn't know anything, but luckily now I know what I'm doing. When I turned 40, I look back when I was 30 and I was stupid, and now I'm just about to turn 50 and I look back and I'm 40 and I realize how stupid I was, but at least I know what I'm doing now. Well, so we're looking back 20 years.
The corporate
obviously looking forward 20 years, the corporate version is the same.
Awesome. Well, it sounds like the future is bright for you guys. Congratulations on 20 years.
Thank you.
Yeah.
Thank you.
And we'll talk more, I'm sure, in the future.
Okay. Thanks very much.
You bet.